In this lesson, we're going to learn how to find the sum and difference of radical expressions. In other words, if we have two radical expressions added together or subtracted, so sum and difference, how in the world do you combine them, and can you combine them together? We know that if we look at just linear or polynomial expressions, we can only combine terms that are like each other, meaning they have the same variable and the same exponent. The same is true in its own way of radicals. In order to combine two radical expressions, they have to be what are called like radicals. What does that mean, though? So like radicals here have the same index number and the same radicand. Okay? In other words, they're the same exact radical. So looking at some of these examples down here, which of the following sets of radicals, or are the following sets of radicals like radicals? So taking a look at this first set right here, I know by looking at that they are not like radicals. Now they both have the same radicand, the same piece underneath the root, but one's a third root, the other's a square root. Therefore, they're not like radicals. Okay. This next one here, you've got the fourth root of 2x and the fourth root of 2x. This one, you can see those two are identical to each other. These are like radicals. Like radicals have to be identical to each other. This last one here, even though they're both square roots, the radicand underneath the root symbol are not like each other. So these are not like radicals, because here I've got a 32t, here I've got a 24t. Okay? So they're both square roots, yes, but they have different statements underneath the radical symbol. Okay? So what is this process of how we sum and find the sum and difference of radical expressions? So sum and difference of radical formula. Here's how it works itself out. If you have a to the nth root of x plus b to the nth root of x, it equals a plus b to the nth root times the nth root of x. So as an example here, maybe we would have something like 3 times the fourth root of x plus 6 times the fourth root of x. So what this formula tells me is, if my two radicals are like radicals, which they are, they're both fourth root of x, they're identical to each other, I can combine them into a single fourth root of x. And what am I doing to the coefficients in front? I'm adding them together, just like the operation between the two. So 3 plus 6 is 9. So it turns into 9 times the fourth root of x. The same exact is true with difference, with subtraction. So as an example here, what if we had 5 times the seventh root of 3x minus 8 times the seventh root of 3x. Okay, so here I have the difference of two radical expressions. Looking at this, both of the radical expressions are identical to each other, so they are like radicals. They're both the seventh root of 3x, which means I can find the difference of these two by combining into one seventh root of 3x and doing the subtraction with the coefficients in front. That is 5 minus 8, which is negative 3. So we end up with negative 3 times the seventh root of x. Okay, so these are the two tools we're going to need as we progress and take a look at the examples that we're going to look at in regards to combining expressions that have like radicals. So let's go ahead and take a look at this first example here. It says this: simplify the following radical expressions by combining like radicals. Okay, so we have a negative 2 times the square root of 24 minus 3 times the square root of 6. Now right off the bat, I notice that I cannot add these two expressions together because they do not have like radicals. Yes, they're both squares, But in order to find the sum or difference, that's add or subtract two terms, they don't just have to have the same radical, in this case square root, they have to have the same exact thing underneath the radical. Here I've got a 24, here I've got a 6. What we can do though is we can try to simplify one or both of these so that they do have the same radical. Okay? I notice right off the bat that 6 goes into 24. So here's what I'm going to do. This first term with the negative 24, I'm going to split it up. So I've got negative 2 times the square root of something times the square root of something. Well, I want to try 6 first. 6 goes into 24 4 times. So I can split this up into 4 and 6, root 4 and root 6. Okay. Well, it just so happens that root 4 is a perfect square, so I end up with negative 2 times the square root of 6, which works out to be negative 4 times the square root of 6. And I still have a negative 3 times square root of 6 being subtracted from it, or 3 times root 6 being subtracted from it. So you can see through this process that after simplification, I end up with two terms with the same exact radical, which means now I can find the difference between these two. So what does this equal? I combine both root 6's into a single root 6, and I do the difference of the coefficients. That is, what is negative 4 minus 3? If you're already at negative 4 and you take 3 more away, that's a negative 7. So you end up with negative 7 square root 6. Negative 7 times the square root of 6. Great, so we see the process is if we need to simplify any of the radicals to try to make as many of the radicals in each term like each other. So let's take a look at this next one here. We've got 2 times the square root of 6 minus 2 times the square root of 54. Again, we have two terms that do not have the same radical. Therefore, they are not like radicals. So, what do we need to do? Well, again, I see that 6 here goes into 54. So I'm going to focus on simplifying this 54. So it's a negative 2 times the square root of something times the square root of something. Well, 6 goes into 54 9 times, so I'm going to split this up into 9 and 6. Again, it's advantageous for two reasons. Number one, I'm going to have a 6 or root 6 to match the root 6 in the other term, and root 9 is a perfect square. It becomes 3, so it's negative 2 times 3 times the square root of 6, which becomes negative 6 root 6. But remember, I have the 2 root 6 in front of it. So I've got 2 root 6 minus 6 root 6. So that difference right there, again, if I have the difference of two terms where the radicals are like radicals, I keep that like radical of root 6 and I do the subtraction with the coefficients in front. 2 minus 6 is negative 4. So negative 4 root 6 is now my final answer. Okay, let's try some where we're working with third roots instead of square roots. So here I've got 4 times the third root of negative 32 plus 5 times the third root of 4. Again, I don't have like radicals, so how are we going to deal with that? I'll always start working with the bigger one to try to pare it down to the smaller one. So what I'm going to do is I'm going to work with this third root of negative 32. So I've got the 4 out front, and I have to split it up into 2 third roots multiplied together. And what I'm going to do is I'm going to look at this 4 right here. I'm going to divide 4 out of negative 32. And I believe I get negative 8. So I'm going to split this up into negative 8 and 4. So I got my third root of 4 to match this other term. The question is, does the third root of negative 8 simplify? And sure enough, it does. We end up with 4 times the third root of negative 8 is negative 2, because negative 2 times negative 2 is positive 4 times negative 2 goes back to negative, and then 8. So that's the third root of 4. So this simplifies then to negative 8 times the third root of 4. And then we still have our plus 5 times the third root of 4. So simplifying that down, I now have two terms with like radicals. They both have a third root of 4. And I do the addition between the two. I sum the two coefficients. Negative 8 plus 5 gives me negative 3. So my solution then, when combining those, is negative 3 times the third root of 4. Okay, two more examples. In these two examples, I'm actually going to have more than just two terms added and subtracted together. We're going to have the sum and difference of 3 terms. Okay, so let's go ahead and take a look at this first one right here. Right off the bat, I see that these second two terms here and here, they both have the fourth root of 3. So those already have like radicals. The question is, can I take this term and make it have a like radical with those? So let's work on this term right here. We've got to split this up, so I'm going to go 3 times the fourth root of something times the fourth root of something. Now, because I want it to match the fourth root of 3's in the other two terms, I'm going to try to divide 3 out of 48. And when you divide 3 out of 48, you get 16. So it ends up splitting up into 16 and 3, which works out really nicely because the fourth root of 16 is 2. 2 times 2 is 4, times 2 is 8, times 2 is 16. So the product of 4 2's gives you 16. So the fourth root of 16 is 2. We've got 3 times 2 times the fourth root of 3, which gives us 6 times the fourth root of 3. And then we have our minus 3 times the fourth root of 3 and plus 2 times the fourth root of 3. Those coming down from there and there. Great. Now what's nice is, since all 3 terms have the same exact like radical of 4 root 3, I can simply take and do the addition and subtraction down the line. So 6 minus 3 is 3, plus 2 is 5. So that gives us 5 times the fourth root of 3 as our final simplified expression after adding and subtracting, finding the sum and difference of radicals. Okay, last example. This last example is going to illustrate that these problems don't always work out so nicely. Sometimes it's impossible to combine two terms. So let's go ahead and take a look at this one. I've got the 3 times the square root of 5 plus 2 times the square root of 54 plus 2 times the square root of 20. My smallest radicand here is the 5 right here. So I'm going to try to make my other radicals have a 5 left underneath. How do I go about that? I'm going to focus on this last one because I see really quickly what I can do. I could split 20 up into root 4 and root 5 because I know 5 goes into 24 times, and advantageous because square root of 4 is 2. So this here turns into 2 times 2 times root 5, which is 4 root 5. A positive 4 root 5. Great. So I now have a root 5 in this term to match the root 5 in the first term. However, this middle term here, can I get that to have a radicand of 5 left? And I can't, because 54 is not divisible by 5. There's no way that I can get a 5 left underneath that square root. But I'm going to go ahead and simplify as much as I can. I'm going to try to find a pair of radicals where the radicands multiply to 54, where one of them is a perfect square. And I think I see 9 and 6. 9 times 6 is 54, and that helps because 9 is a perfect square. It is a 3. So you have 2 times 3 times the square root of 6, which gives us 6 square roots of 6. It's addition between those two, and I've got a 3 times the square root of 5 plus the rest in the front. Okay, so we tried to get all of the radicals like each other, but we couldn't. Only the first term and the last term are like radicals. So I can go ahead and combine those by adding, because it's addition right here, adding the coefficients to get my 7, and then square roots of 5. And then what I have to do is just plus 6 times the square root of 6. And I leave them separate because I can't combine them. They are not like radicals. They're the same root. They both are square roots, but one's a square root of 5, the other is a square root of 6. So I cannot combine them. So we can see that in some situations, not all terms are combinable. So we just leave them separate. We don't combine them unless we legally can.